title of the talk is using UNC's research data center to analyze demographic microdata, an example using post-hurricane migration patterns. The goal here is twofold: to sort of provide an overview of what the RDC, what kind of data it has, and what kind of research practices it enables. So that's sort of general, along with some specifics in terms of what the research environment is like and what the processes are, both for getting access and then sort of getting results out. And then the second half of the talk is a concrete example, which I think, so it's using American Community Survey data with the geographic linkages to analyze sort of post-hurricane migration patterns, and sort of emphasizing one of the benefits, the kind of additional variables that you get using the research data center. So even if that doesn't necessarily align with your like specific research interest, I think it might be a concrete example to sort of illustrate what you can do with access to the RDC. So first, like, what is an RDC? It's a secure computing facility, a room in a sense, and it's just here up on the third floor. And it's very nondescript room. There are no windows. It's very like austere environment, but it gives you access, direct access to places where the data is stored, so administrative level or census data that has additional variables, additional data sets in it. This is a much nicer, the data center here is a branch of the Duke data center. And here, since CPC is a modern office building, unfortunately, like in some ways, the windows don't open. It can feel a little bit stifling sometimes, but it's a modern building. The data center, the main branch of this data center, which is at Duke, is in their former chemistry building, and it's like on an overhanging floor that has poor insulation. And so in the wintertime, the cold like comes in, and the bottom parts of your legs get cold. It's hot. So there's some specific advantages with UNC's RDC. So one way to think about this is that you can think about the data that's available at an RDC like an iceberg. There's public data from the census that's available to everybody, and then there are aspects of the data like beneath the surface, which include restricted access variables that you wouldn't know about or wouldn't have access to. And then moreover, there's the possibility of linking multiple kinds of data sets together. So administrative data, sort of the exhausts from administrative data systems, can be linked into public use data, and that's sort of the example I'm going to go through today. Here's a map of the RDCs in the United States, and you'll see the Duke and UNC ones right here, and it's an expanding network. We're fortunate to have, in this case, like really close proximate access, but there are lots of places still where researchers aren't close to an RDC. When this is the one that opened up in Colorado, but before that, there was nothing in this huge geographic curve. Common users of, yes.
What did the red dot signify on that map?
I think at the time that was ones that were just about to open.
Oh, okay.
Yeah. Oh, and by the way, feel free, like particularly since this is a audience of 4, like and interrupt and ask questions. That'll be more entertaining for me. So the idea of the RDC is to provide access to researchers, like sort of broadly defined, to people within the academic research community, grad students working on dissertations, for instance, faculty researchers, and people who are part of those teams. It's not really intended, I think one important point at the beginning is it's not really intended for descriptive analysis. So for instance, you could say one of the advantages you can locate individuals in the ACS or other data sets down to the tract or block level. But it's not intended then to enable you to do a descriptive analysis at the block level and pull out, say, a map. The goal is to protect the privacy and confidentiality, to really restrict the output to coefficients and results of models. So when you're doing the matching, like you're seeing a lot of detail that wouldn't be available to public researchers. But then to make sure that none of that information is then being released, the disclosure rules really make sure that these are the results of models. So just sort of sketching out like the different kinds of data that are available. Existing public data with a twist would be like well-known public data with additional restricted access variables, such as the American Community Survey, which I'll be talking about today, that has geographic location of the individuals who answered the questions. In CHS data with restricted variables with geocodes. SIP, Survey of Income and Program Participations, which is the rolling 4-year survey, provides like the best demographic, like longitudinal data set in the US that's continually updated. And here again, you get tracked geocodes. And interesting, you also get, I didn't know about this before. I worked on the data, you also get names, first names of respondents, which is sort of interesting if you think about the way that names like encode an aspect of cultural preferences. So I was using this data, looking at bilingualism among immigrants, and matching it to ACS data that also had first names, which I used to create contextual data. Other data sets are ones that you wouldn't possibly even know about because they're administrative data sets or data that's created from administrative data. An example is the longitudinal employer household data set, which is a matched employer-employee data set created from unemployment insurance records at the state level. And what that allows you to do is follow all privately employed, 97% of privately employed workers in the US as they move across quarterly data on their earnings and the firm that they're working for. And so with that data, you can reconstruct essentially the employment characteristics of all firms in the US, along with their like spatial location. And then data formed by linking cross data sets. So the PIK, which is a protected information key, is a scrambled version of social security number that allows you to link individuals across individual microdata across multiple data sets using the PIK. And for instance, census, the decennial census is matched to the PIK with about a 97% accuracy rate, which means that even people who didn't include their social security number, but have their name and address on the government's version of the decennial census or the ACS, then have a PIK attached to them and then can be matched and merged to other forms of data that are in the RDC. So just to highlight some of the key, like some aspects of sort of different types of data sets that are available. So for demographic data, which is the real focus of today's talk, here are some key demographic surveys. Decennial census, you get geographic detail down to the block. ACS also down to the block. So the ACS is a 1% yearly sample of the US population. The CBS data gives you down to the tract. And you can see here, like if there's some component of your data that's spatial, some component of your analysis that's spatial, where knowing the geographic location of a respondent at the micro level, and then adding in contextual data, like aggregate contextual data that you could bring in and bring into the data center, can be merged, gives you a lot of leverage in terms of thinking about what's going on at the local level. Criminology data, for instance, the Criminal Justice Administrative Record System gives you longitudinal administrative data and people who've been involved in the criminal justice system. Can link it to other census data sets. You could look at, for instance, you could match it to the LHD that I mentioned and look at post-incarceration economic outcomes. Geographic mobility data, in addition to what I'll be talking about today with the ACS, the government has a master address file, which is a longitudinal record of everybody who shows up on one form of data or another. And you could use that to study migration. It's pretty accurately linked to the ACS data. So if you had, for instance, you could expand on what I'm talking about today by linking the ACS data, which gives you a sort of a snapshot of where somebody is at a particular point in time, along with a 1-year migration history. You could also match that up to this master address file and get that person's longer term history of where they lived.
So,
yeah,
given that this exists and is linked to those other files, when you say like the decennial census, you can see it at the block level for a person. Does that just mean like you could also see their address? I guess I'm confused about.
Well, you won't see their address. The government, this master address file will have their address in it. which you wouldn't see, but you could link to it. So from that file, for instance, you could code the block that a particular case is in. And so as a result, you could then follow, it'd be possible theoretically to create like a longitudinal block level analysis of geographic mobility for everybody who's in the master address file. And so in the ACS data, for instance, I'll be talking about, the public use data just gives you the public use micro area, or PUMA. But then with the version you have inside the data center, you know, there are other variables that tell you, for instance, what tract and what block that person's in. And of course, I mean, the government knows the address, but the restricted access version doesn't give you access to the address.
Okay. And then this as an address indicator.
This would have, yeah, this then would have, this has all the address data longitudinally. You wouldn't get access to this, but you could use it to create, you know, a block level variable.
Over time.
So that this, like the version of this that then would be in the data center would be the same sort of thing you'd have in the ACS, which would be tract and block level data for individuals. This in some ways would be like, the idea here is this is sort of like this would be the gold standard of geographic mobility. And it suggests that the government, with this administrative data set, which is used to track people in terms of sending out government forms and things like that, postal, like this is sort of like the administrative result of the postal service. Would be an interesting parallel to sort of things that exist in the private sector, like credit history reports or things like that. Health mortality and public program data. And I think here, obviously, within each person's individual research field, the idea would be take a look at the available data sets and sort of brainstorm about kind of linkages that might be possible. Because what it really is a sense of sort of exploration to see, is there some variable, some topic where the leverage or the value, potential value added, given the existing research, that could be unlocked with the kind of data you could add. And that's I think you would be looking for. Economic data sets, lots of data that can be batched in. In particular, I mentioned the longitudinal employer household data, which can give you a quarterly dynamics of firms, both the hiring, departures, but also the wage levels and sort of internal wage distributions at the firm level. Okay, so one important thing to mention would be like the cost of using the RDC. So ideally, the goal here is sort of outreach in terms of trying to encourage more use, to try to find, like, is there a research project related to what you're working on that would be beneficial with the kind of data that you could access in the FSRDC? Because of a recent, you'll see this in the next slide, the OVCR's office had funded the RDC, UNC's participation in Duke's consortium for 15 years. Recently decided to move us towards a seat fee schedule, which is $2,500 per year per person in a project. The person who's doing the data analysis, you could have a 4-person project, if one person was using the data center, that would be one seat fee. $2,500 per person for people in Keenan Flagler or College of Arts and Sciences, because both of those units kicked in money to support the center, and $5,000 for UNC faculty outside of those two units, $13,000 per person outside of UNC system as a whole. And that $13,000 is sort of consistent with what other data centers are charging for external researchers. For grad students, though, no cost of using the RDC for a dissertation project. It would only be a cost if you're using it for a project with a faculty advisor, if you're the person going in doing the data analysis. These fees could change. Part of the challenge right now is for the RDC to be self-supporting or virtually self-supporting. The overall costs per year, which is really the cost of paying the Census Bureau's employee, it's about $178,000 per year. And so some of that money has to come from charging seat fees. And the cost is shared between UNC and Duke and RTI. The process of sort of accessing the data involves a pre-proposal stage, which means sort of sketching out your idea, thinking about what data sets you might use, and then sending it to Bert Greider, who's the census administrator with a long history of experience. And then it's sort of back and forth. He'll let you know sort of what the specifications are and the format that the proposal would take. It's a little bit different than a grant proposal. In the sense that the census wants your proposals to be accepted, but sometimes it's a matter of sort of fine tuning it so that it fits the requirements in terms of how the census can make data sets available. And that's a sort of back and forth process. Eventually goes, after Bert gives it a green light, it goes to the census. Can take 3 to 6 months, followed by about a 3-month period of getting special sworn status, which gives you an ID card that allows you to enter the data center. So I think the point of going through this is that there are several steps involved in getting access. The process has been sped up, or at least it was prior to 2024. And that this process, the process of getting SSS and then getting the data center unlocked for you is much quicker than it was previously. Yeah.
I guess with the proposal, do you need to like say what the specific research output will be so like they can
Yeah,
approve
so that's a
it?
good question. So it's part of it is describing, as you would in a grant, like what the purpose of the research is, what the what the substantive area, but then it's a little bit more detailed. So you sort of have to sketch out what the modeling strategy is and what the output will look like. And it's sort of and think about it sort of like an umbrella. You're saying here are possible papers that are going to come from the analysis, and you can identify more papers than you actually do. But sort of, and they even want the detail in terms of what kind of model you're going to run, and it can be flexible. So the idea is make it broad enough that if you change go from a logit model to a linear probability model, say that that's not so much an issue, but sort of getting an idea of what you're proposing to do and being concrete enough about it that they can really sort of evaluate what the potential risks might be.
Okay.
And then sketching out what are the key excessive variables. So it's not so much as like, you want to add a variable in, you didn't have it in the list, but rather like what kind of blocks of variables, what kind of type of analysis you're going to conduct. And if you find yourself in a situation where you have an existing project that you're working on and you want to modify it, then you can apply for an expansion of scope. That's actually really exactly what happened with this particular project, because it was a project where I applied for using the restricted version of the ACS to get geographic detail in the SIP, the Survey of Income and Program Participation, to follow individuals over time. And it proposed to study both labor market dynamics associated with changes in the occupational structure at the geographic level, and also the social incorporation of immigrants. And this had nothing to do with weather shocks and hurricanes. And so that was related to the structure of the data. Like the data was all there, but the contextual thing I was adding in was now different. So that was an expansion of scope. And I just had to go through an approval process, which was, in that case, it was just a week or so. Yeah. So it was much easier than doing a whole new project application. If it were to be something where it totally, both the data structure and the variables and the topic were different, then they might say, okay, add a new proposal, perhaps. But in this case, because it was like one step away, really, with a similar data structure, that's what allowed it to pass.
You get your ID card, is the fee needs to be paid before you get your ID card, I imagine? Or you like free?
There may be recently, I think there may be a fee to get the special sworn status, but once you get that, that's good for life. But the census itself doesn't charge for data use, so that there wouldn't be any fees involved other than this potential fee for the special sworn status. When I got mine, there was no fee. But the use of census data itself is free. The only fees then are involved like at the specific data center level, which is getting access, like stepping inside the data center once you have everything approved.
So if you get sworn status here at UNC and like for some reason you move to another state, like can
Oh,
you,
that's fine. So it's a national thing. So you have to go to a federal center to get the SSS. So it's not, it's UNC itself isn't involved in that. That's a census or federal government related thing.
I guess what I'm saying is like, if you have, once you get access to this RDC, for example,
You can transfer it.
yeah.
Yeah.
But you still have to probably contact them and figure, it's like there's still a process, right? It's just not like you can just walk into the next RDC and.
Right, right. It's not like a gym
Yeah.
So yeah. But there have been people who, like, there have been federal employees who were on vacation in the RDU area, and then they got access here. Researchers who, for whatever reason, moved and just transfer their access to like a different data center.
But there is a process, basically.
Yeah. And so here, what I was talking about before about this flexibility and sort of conversation that you would have with Bert about what makes a successful proposal. Scientific merit, multiple related research questions. So one suggestion would be, you may like get a brainstorm and be like, here's the project I want to unlock with the variables or data sets that you would access in the RDC. One important suggestion is to sort of expand that a little bit. So it takes long enough to get access in terms of the 9-month period, but then you have 5 years, typically 5 years of access, with the possibility of getting 2 additional years for R&Rs. So given that length of time and the time sort of investment involved in getting access, one idea is to make sure you're sketching out 3 to 5 papers, even if you're initially drawn to like one specific one, but sketch out a broader sort of research proposal. And that sets you up for sort of unlocking things once you get in, because sometimes it's like a chicken or the egg. Only when you're accessing the data, only when you're doing the analysis, only when you're seeing additional variables that you didn't even suspect were there, do you think, oh, I could actually do this. And so if you've written a broad enough proposal, then you're in good shape. And this sort of refers to your question earlier, sort of having enough of a detailed methodological strategy. And one of the things Bert will do is sort of say, okay, here's your model you suggested. You could generalize it a bit, and it would be sufficient for the census, but it gives you a little room to operate within that. And this part is the back and forth, like demonstrating no disclosure risk and/or proposes a plan to deal with high-risk samples. So depending on the specifics of what you're going to do, like, could there be a disclosure risk? Could it, is it possible that somebody could look at your results and identify a person or a firm in the data? And so that's where they'd be really clear about, okay, you might need to modify the research plan if that's the case. This sort of again follows up on that, but typically it's a revise and resubmit sort of situation, a friendly one, in my experience, where they're like, okay, they're giving you comments back. Sometimes it's not like a little bit like a journal review, like there could be critical comments in there, but it's usually a plan to deal with them. Only in cases usually where there's stubbornness on the part of the researcher, like you get comments back from the census and they're saying, if this is a potential disclosure risk, you need to respond to it. But if you persist and say, I'm not going to do that, it can get rejected. It's different than a grant, where the cutoff line is like 5% or something. This is more like, higher 70% or something. If you work with them and are operating good faith, I think the acceptance rate is pretty high. You can see, and these, I can send you these slides if you want them, but and I think if a version of these slides are actually online at the RDC, the UNC RDC website. You can see past project metadata as well as working papers and technical reports. Some aspects of the logistics of working in a data center, which are can be a little bit tricky. So you're operating sort of like a terminal, a computer terminal, not a Windows environment. You can, once you get used to that, so you submitting jobs on Unix via the terminal window rather than working in Windows. You can open an X window, so you can get a Windows version of R or Stata, for example, to test or write your syntax file. But then to submit the job, particularly the large job, you got to do it through the terminal prompt. It takes a little bit of getting used to, but once you get used to that, it works fine. And then the kind of resources that you have available are just astounding. I always got like nervous, like running a job, like at first, like 2 GB or 4 GB. And then I realized that people all around me running jobs with like 100 GB and stuff. And like my jobs were like really tiny. And eventually, like if you start to crash the system, you'll get emails, like what's going on, you made a mistake. But the kind of like, it's a huge amount of resources because the scale of the data is really gigantic. I talked a little bit about this disclosure avoidance. Any output is going to go through a disclosure review board, which is really for both, it's safety, making sure that this valuable resource doesn't get misused. And so every cell, every part of your analysis that's coming out will be reviewed to make sure there's no risk of disclosing anything about the characteristics of your sample, anything about the individuals or firms represented in the sample. So sometimes the issues would be if you have very small cell sizes, small geographic areas, or if like the volume of output is within a certain ratio of the overall number of cases. It takes time to do that final part, and then it takes about 3 to 4 weeks to come out. So something to sort of plan ahead if you had a conference paper with like a real like tight time deadline. In the worst case, though, you can usually take out a table of results with pluses or minuses and sort of significance. So you can talk through analysis you just finished. That's quicker to get released. Okay. Any questions like on that first part? Like a sort of broad overview? Yeah.
Yeah, so I think I worked in like this they call it the SRW or Secure Research Workspace
Mhm.
For one of the projects I worked on, and I think it's like a closed system, like there's no internet access or anything. You
Mhm.
just have to use whatever documentation that's built.
Right.
So
Mhm.
is that kind of how it is?
Yeah, same sort of thing. So no use of the internet within, like the terminal itself is not, other than a direct connection to DC, there's no internet connection. Anything you want to look up, you got to step outside the room. Yeah, so it's obviously if you're used to having like another window open to help with syntax, that could be like going back and forth.
Yeah, like say you have some like SAS macro that you like to use, like can you
Oh, right. You can have that like if you had a macro that you wanted uploaded, you can do that. So you just send it, essentially you're sending to the admin.
Oh, and
They
then,
check it over to make sure there's nothing. Usually stuff going in is fine.
oh,
It's when you want to take stuff out that it can become tricky. And so that would be fun. And because the volume of people doing like heavy duty stats analysis, I was always surprised like how many like working in Stata, how many of the ADU files I wanted were already there, things like that. It was only an issue when you had to like step outside to like look up the syntax or something and then sort of keep it in your mind when you walk back inside.
Huh.
There are some situations where like you're always worried, like, are you walking outside the data center? Do you have your keys? Like, do you have your badge? That's the key thing, like walking out the badge so you can get back in. There was Bert told me one story of during a previous government shutdown where a researcher walked out with her badge right before midnight, went to the bathroom.
Yeah.
But she left her backpack, her key, and her wallet and car key in the data center. Then the clock struck 12, and immediately, like they were right on the ball. Like clock struck 12, and the data center access got shut off. So she didn't have access to her like card keys or apartment. They had to wait until like I think eventually an administrator let her in, but it's pretty harsh, like
Yeah.
harsh turn of events. Sometimes I was paranoid, like making sure I had the card to get back in.
So is it closed right now?
It's closed right now, yeah. Like nobody can go in.
oh, there's a shutdown.
Yeah.
Dang.
Okay, so here transitioning to this like specific paper, we had the goal here being to sort of emphasize the data linkages that are in this paper and sort of how it attempts to make a intervention into this literature because of the specific benefits that this data brings. So the background is the underlying issue of climate change, increasing propensity and severity of hurricanes, hitting the southeastern part of the US. And in a way, like some of this literature looks at the projections for long-term changes. So people living in coastal areas where the projections for sea level rise means that eventually, like, it's going to be untenable to live there. And then some of this literature then tries to project where these people are going to move. In a way, though, the hard thing or funny thing is, depending on how you look at it, from a demographic perspective, many of these areas are still net gainers of internal migration. So they're still gaining people. And it's one of the challenges to try to sort of anticipate the migration system, the way in which migration systems, sort of patterns of migration or propensities of migration from areas that are being hit by sort of increasing propensity of storms. But the data sources are limited. So the key challenge is that a lot of the existing, that might be the next slide. A lot of the existing data on how human populations in these areas are responding to storms, hurricane damage, flooding, et cetera, is based on sort of inadequate or partially adequate demographic data. A lot of it is county level migration. So we know flows between counties. The IRS tax data provides county to county migration flows is one source of data. But the problem there is it's not individual. You don't know characteristics of the individuals who are migrating in many cases. Some of the data sets, you also don't know where in the county they were migrating from. So it's not track level. Other data sets have, like the panel study of income dynamics, which is a longitudinal study of individuals. The problem there is thin data coverage. So it's, you can look at individuals and you know the tracks that they're in, but you don't have, the case counts are pretty low. And I mean, a key issue that this paper tries to intervene on is sort of what's going on within these counties. So there may not be much evidence of net migration out of the counties, but we sort of have a limited understanding of how the destruction of a hurricane and the flooding might be causing population redistribution within the counties. And there, the advantage of having the track level information from the ACS is really beneficial. So the ACS data, which is a 1% cross-sectional data set, has a retrospective question on migration. Where were you living last year? And in the restricted access data, that gets coded all the way down to the track level based on the address that they give. So you can find, so for instance, somebody who's living in California, but was living in New Orleans a year ago, you ideally, you'd be able to identify not only the city, but the tract that they were living in. So it sort of gives you the ability to back the data up 1 year. So who was living, say, in New Orleans a year prior, and where did they migrate, either internally within the county, or did they migrate sort of across county lines? Okay, so I've covered some of this. 1% sampled U.S. population, restricted use data to get the geographic location, both current geography and previous geography for movers. Now it's, it's limited in some sense in that we're not getting their full migration history. That's where potentially the master address file could come in to give you the demographic characteristics, education, gender, race, et cetera, age, and then provide a longitudinal snapshot beyond that 1 year, I think would be a real big innovation. The advantage though here is the size. So you're getting 3 million observations per year, which then when you go to the county level, so this analysis is going to look at counties that experienced hurricane events between 2005 and 2019. And let's see, I'm identify counties that experienced hurricanes from the SHELDAS, the Spatial Hazard Events in Loss database, which is an external data set that I merged in. And that provides sort of aggregate county level losses from natural hazards, a whole range of natural hazards, county level crop and non-crop property damage. So that's a source, that's going to be the source of property damage, county level property damage in the data. And I'm also going to use it just to sort of select counties that were hit by hurricanes. And that is the number of counties by state, listed here on this map. So it's really covering, and I know that the theme for Research Week is North Carolina specific analysis, and North Carolina is represented here. There's also a caveat there, which is that to use the ACS in the data center, you can only pull out results from a geographic area that has the total collected population greater than the smallest US state, which is Wyoming. That sounds like sort of a tongue twister, like a puzzle. But I think this population in Wyoming is 300,000, something like that. And so that means that in fact, if you zeroed in on this, it's going to be specific counties. This map should be more detailed, identifying the counties that are in the data. And the thing I had to make sure was that the combined population of these counties was greater than the population of Wyoming. That's the sort of geographic restriction. So what you couldn't do is study just North Carolina counties with this data. They can be included as part of a larger data set. In this case, obviously hurricanes hitting the south and southeast of the US, but it couldn't be a North Carolina only analysis unless the range of counties we were including that were hit by a spatial event were greater than 300,000. Yeah.
Could you run a model with the whole data set that spit out state specific effects and report the coefficients? So it was like, oh, like the effect of a hurricane in Texas is this, the effect of her, like, could you do that? Or is it like,
Well, you could have that's a good question. You could have a model, like you could have a multi-level model where there was a random coefficient, say. So you were letting the effect vary by like a geographic area, which would be a good, and then including variables that we're trying to explain why the effect might be different in different states, say. But you couldn't pull out the effect of it, like you couldn't then pull out the coefficient for North Carolina unless the population of North Carolina that was included in the sample was greater than 300,000. So it'd be, you have to,
okay.
that's one of those things where you're getting like access to really phenomenal data, but you'd have to be careful. And then I think that's part of the give and take coming in too, like Bert with his experience sort of getting these projects through the disclosure process, the acceptance process would help you, like, what would you have to do so that such that you could do that kind of analysis? So you could run models with spatial heterogeneity in a multi-level model. The question would be what you could pull out that would tell you what, you could say there's variation in the coefficient and these characteristics of areas explain some of that variation at the county level. But then you couldn't pull out a county by county list of the coefficients.
Okay.
So it's more like coefficients rather than maps would be the focus. Yeah.
So is the 16 counties in North Carolina, those are the 16 counties that had a hurricane but also meet that output criteria?
Oh no, so that they don't, so that to be in the data set, like since these are being analyzed as a whole, the advantage of that is I can include any county that fits the criterion that was used was a county where the hurricane damage was 10 million
Okay.
in a particular year. So there, I think it could be that in the like the R&R version of this paper, I might relax that. So there'll be more events. But part of the goal was to sort of set a threshold for like in 10 million really isn't that much damage when you think about it spread out over a geographic area. I think you can reach that pretty quickly, but it does at least define like a discrete number of counties that are being affected by hurricanes. But then they're all part of the data set, which I'll show you in a second. So they're contributing cases, but I'm not doing a county by county analysis. That's probably the difference.
So is the right way to think about it that, because we have sort of started this process, but are struggling a lot with this particular restriction. Like, I just don't understand it. Is the way to think about it that like the count, like sort of in a regression, if you think about like all of your crosstabs, right? Like your many dimensional crosstabs that are going into a regression. Every single one of those cells. No, that's not.
Oh no, so the data here, like when I look at the data, I'm going to have 160,000 individuals across these. Each one of them is in one of these counties. But then the regression coefficients, which you'll see, it's a single column of results where there are characteristics both of individuals and of counties and of tracts that are explaining propensity to migrate.
Okay, but like, so you're spitting it out by year, oh, I guess this. is
Well, this is
by year.
the nice thing here. This is the data. This is the external data set that showed us. This is stuff
Yeah, yeah,
before I send it in. So I can do whatever I want with the
Yeah.
public version of these external data sets, like to say, here are the counties that were hit. In fact, I could even do an analysis with public level data that could be much more descriptive. In there, I could say, here's for the, from the public side, here's what happened in these counties in North Carolina. Here's the damage, and you could do sort of a preliminary analysis going as far as you could with public data. Then you jump into the restricted access data to do like the analysis that couldn't be done on the outside.
So I think I figured out a better way to ask my question. If you wanted to show, for example, the effect of a hurricane on migration year by year
Mhm.
in your sample, would it have to be the case that in any given year,
Right. So each one of those
treated
years,
like the exposed county populations needed to be bigger than
Right.
Wyoming?
Yeah.
Not just the whole, like, because your sample overall is big enough, but you couldn't report out 2013 if in 2013 only 4 counties actually got hit by a hurricane.
Right. Yeah.
Okay,
You could, and
Okay.
obviously you could do that analysis in the data center. What you could bring out would have to be anytime there's an interaction term. So in that case, it would be a
Yeah.
year interaction or a separate analysis by, say, 2009.
right.
That then would require a disclosure analysis of that particular analysis, which would identify what's what's the population represented by those areas.
Okay.
You could obviously, if you found a way to like broaden the way you imagined it, like you could have, well, I guess there the problem would be, if a county was part of your sample wasn't affected by a hurricane, they're not contributing anything to that variable, which is the hurricane event. So that's the issue. So
So
I think you
there is
probably have to
every-
pool across years.
Okay, it's for every coefficient that's reported that samples the records contributing to that coefficient.
Right. Mhm.
Okay,
If it's a dichotomous variable, if it's a continuous variable, it's a little
then
different.
everyone is, yeah, okay.
Okay, so the Sheldon data sort of identifies the sample, 189 counties spread over 12 states. And some of these counties are hit multiple times, show up multiple times. And then I'm adding in, so part of the final analysis ended up adding in 2 additional data sets. And these were both sort of, this was user contributed data, so outside data being added that sort of expanded the scope or changed the analysis. The FEMA National Risk Index, which was advantageous because it had information at the track level. So the problem with Sheldon is it's just a county level damage report. It doesn't tell you, like, was your house damaged? Nor does it really give you any spatial variation within the county. The National Risk Index tells the level of exposure, and in fact, it's a proportion. So the proportion of people in this tract who are at risk of coastal flooding or at risk of river flooding. And that's still not down to the like ideal data set would be like, I want to know what happened to your house, but this at least gives you spatial variation because we're trying to predict how, in particular, how people are moving within counties. And then the NOAA, National Oceanic and Atmospheric Administration rainfall data, what I did is wanted to get some sense of the magnitude of how much rain was dropped. And so I pulled the NOAA data for the time period around the hurricane to get the total rainfall amounts, and then took the log of that and added that as another moderating variable. The analysis is going to consist of 2 linear probability models of within county and cross county migration. And the structure, the advantage of the data gives me the ability to look essentially like a before and after analysis. So what I was concerned about was that there are some counties that might just have higher migration rates at a baseline. And so I didn't want that to contaminate the results. And so I'm thinking about this as a panel. So for each county that was hit by a hurricane event, I'm taking demographic data from that county in the 2 years prior to the event, then the year of the event and 2 years after. And so it's a sort of before and after analysis. And then I'm going to use county level fixed effects to net out the migration level of that county from the baseline. So the goal of the analysis is going to look at the impact of the measures of the hurricane severity. So the shelter's damage report, the rainfall level, and then interact those with characteristics of individuals and the tracts that they live in to see if that increased the rate of migration. So the focus is on the interaction terms, property damage and log rainfall as moderators of migration propensities. And then controlling for aspects, average value of the house, like other unique variables that you get from this data, was able to create a aggregate housing value, and then characteristics of the tract and the individuals. Let me jump to the results table. So here's the descriptive table, and this sort of illustrates the kind of descriptive information that you can take out. So these are all of the cases essentially collapsed together, not broken down by county. But then a sample of non-movers, so 1.4 million non-movers in the data, and then a sample of people who across within the county and then across the county. Those two, the difference there sort of gets at the relative value added of this data construction, because we're sort of blind to what's going on within counties after a hurricane. And this sort of identifies like where that migration is coming from. And an extension of this project would also look at where they're migrating to, and then the rate of migration out of the county. And also notice these are rounded. So part of the disclosure rules sort of limit how precise you can be in terms of the numbers that you're taking out. So this is rounded to the nearest 1,000. Okay, so this is an LPM model of within county migration with 4 different models going across. One with no controls the demographic and tract characteristics. Sort of that gets that in a way like basic propensity to migrate, and then interactions with rainfall and interaction with property values. The key findings for the within county migration are that there's no baseline effect of log rainfall and property damage on the propensity to migrate, at least as measured with this data. But there are substantial significant effects in model 3. So interactions with the degree of rainfall that fell on the county, and whether you were at risk for riverine flooding, as they call it, and then significant interactions with housing values. So more rainfall and a higher housing value in the tract predicted within county migration. These are all down here in model 3. So again, nothing surprisingly, the degree of rainfall or property damage in the model with no controls or with controls wasn't associated with a higher rate of within county migration, but things are showing up when it's interacted with more detail on the tract level. So here, river flooding risk and the degree of rainfall, which sort of makes sense. And ideally, you'd want to sort of zero in on these counties. I think that could be done in a way, like you could back out and sort of take a look at the counties that are hardest hit. But that's showing up with data, so an increased propensity to migrate. If your tract is at risk of river flooding, and moderated by the degree of rain that actually fell. Same thing for housing value and log rainfall. Nothing though in model 4. The same interactions with log property values wasn't responsive. So that's coming from shelter's data, like the degree of property damage. And it could be, my guess is like the property damage is probably because it could be highly concentrated or spread out. It's not I think if your house was hit or destroyed, you're obviously going to move. But the coarseness perhaps of the shelter's data, it's just at county level, just aggregate, like doesn't really work well predicting individual migration in the within county model. Table 3 shows the same thing, but for cross county migration. Here, the results are different. here we get across all the models significant effects of log rainfall on the probability of migrating, and some effective log property damage, but very little evidence of moderating effects. Like the same moderating effects that were there in the within county migration don't show up in the cross county migration. There's something rainfall by education, maybe picking up some class differences or capability of migrating perhaps, but otherwise not the clear set of results that are found in table 2. So that's here. Interaction with education and log rainfall. So if anything, this suggests like the benefits of being able to differentiate. Some of this could be like long migration. I mean, the county borders are arbitrary, so some of this could be long spatially distant migration to a different labor market area versus something that might be keeping you with the same job, which is moving out of a particular neighborhood that's at risk. So anyway, those are the key results. But I think the real thing here is like thinking about this as an example of the data linkages that you could do, and how in this case I'm bringing in 3 external data sets to provide contextual information to sort of motivate the analysis, giving a glimpse of sort of demographic behavior that wouldn't be observable in public level data. So, well, thank you for. I'll take more questions, but thank you for being a very like responsive audience, and it's nice to have like 4 people here at least.
There's a line question, someone from online.
Okay, yeah,
I'm gonna sit and ask the question.
Okay, looking at the chat here. Okay, so the question is, how do you handle counties added to the ACS after population change? Imagine you have using the ACS 1%, and this survey is not applied to all counties, or if the ACS 5% is still confidential. Right. So if a county is missing from the ACS, they wouldn't be in the data. If they were added, then you can include them for the time period that they were added. So in this particular case, if a county was added to the ACS data, then they could be part of the sample, and I think that'd be totally fine in the sense that all of the cases here are only in the sample when they appear in the data and are part of a hurricane event. So I don't think that wouldn't be a problem for this particular analysis. I think, go ahead.
Yeah, my question was because it's not then a balanced panel, right, for those counties. If that's what I'm just saying to check if that's something that is happening in your sample, especially with ACS now being implemented at all counties, and your sample is between exactly in the 2010 when some redefinition of the counties and population changed too. For the American Community Survey from 2009 to 2011, you see some counties added or some counties changing, but overall, if you some are appearing, and the problem itself is not appearing or disappearing, is if it's correlated or how hard they're hit by the event, they may bias part of your results of like some disappearing or some appearing with different characteristics because some big investment happened in that area after an event, and maybe some of your zero effects is mostly like you capturing the event in a different way because a big investment happened in between the years that they were not in the data and now in the data.
Yeah, that's a good question. I didn't like, so the counties are identified with the Sheldon's data, and I didn't see any counties that were identified that I couldn't match to the ACS data. So I don't think it's an issue with this analysis, but that'd be something you'd have to be careful about anytime any county that was or wasn't sampled at a particular point in time, it'd have to be something you'd have to be careful about. That's definitely true.
And I have another question. I'm sorry if they with migration, there are some I mean, we will be interested in what happened after an event and how people migrate. but there is a deep, you're maybe more interested in seeing how the migration pattern changes. So there may be some fixed, not just fixed migration pattern at the county level, but cross county. So maybe there is already a pattern of typical migration that happened between two counties that are nearby or they are connected by economic activities. And maybe there's what you want to capture is more when it goes beyond that, right? Like when
Mhm.
it's different to the typical pattern. Have you thought about how to do that part or
Oh yeah,
any?
I think that's an excellent question. So that would be an extension to this analysis, which will look at the sort of migration, the broader migration system. So did the hurricane change the types of counties that people are migrating to? And you could do that two ways. One would be to look at the characteristics of the tracts and like characteristics of the tracts and counties people are migrating to and see if there was a change in those characteristics. Another one would be to model using like a conditional logit approach, would be to model the counties that people move to. And you could test whether there's some sort of difference in the pre or post hurricane migration pattern. And that's definitely something that's relevant for trying to predict what happens in larger scale events. So as like climate change increases and the propensity for these places to flood increases, does it change the pattern of migration of where people move to? And I think that's an excellent question. It's something you'd have to address, I think, with real data to predict the demographic impact of climate change in the medium term. So that would be an extension to this analysis.
Thank you.
Yeah, that's a great question. Anybody else? All right, well, thank you both online and here for attending. And let me know if you have any questions either about specific data sets, getting access, or this particular analysis.